Alright, so now we're going to move on to part 2, doing more examples, good times with derivatives, and the limit definition of a derivative. So, I want you to find f prime of x and the equation of a tangent line at x equals 2 if f of x is 1 over x. So pause the video, find the derivative, find the equation of the tangent line, unpause when you're ready to check your work. Alright, so our answer for the equation of a tangent line at x equals 2 of f of x equals 1 over x should be y minus 1/2 equals negative 1/4 times the quantity x minus 2. Now, how do we get that if you got something different? Well, again, first, over here, I figured out what is f of 2 so that I know the y value when x is 2 of the function. Now, I did the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. So I first ended up with what you see in green here, 1 over x plus delta x minus 1 over x all over delta x. Multiply the top and the bottom by the least common denominator, which is x plus delta x times x. So I multiply that on the top and the bottom. Now I have the limit as delta x goes to 0 of x minus the quantity x plus delta x. When I distribute that negative, the x's are going to cancel and this becomes a negative delta x on top. In the denominator, I want to leave the delta x factored out, but I did end up distributing the x, so I get x squared plus x delta x. Don't get confused. I know writing delta x looks like you have two separate things multiplied, but delta x, remember, is all one term. It's not delta times x. Also, another side note, you are really going to want to know that difference quotient. I'm not going to be giving that to you on a test or a quiz. You need to know the difference quotient. You need to know how to evaluate the difference quotient. Once you've done enough practice, though, it will be just like riding a bike, assuming you know how to ride a bike. So now I can evaluate the actual limit. I can do direct substitution, plug in 0 for delta x, and this term goes away. And so I'm left with the limit of delta x as as delta x goes to 0 is negative 1 over x squared. Therefore, the derivative of f of x is negative 1 over x squared. So I find what is f prime of 2. So I substitute in 2 and I get negative 1/4. So that is the slope of the tangent line. Therefore, the equation of the tangent line is y minus 1/2 equals negative 1/4 times the quantity x minus 2. Next, find f prime of x for f of x equals the square root of x. So here I'm just asking you to find the derivative. So pause the video, unpause when you're ready to check your work. Okay, so here we first use our limit definition of the derivative, plug in the function to the difference quotient, taking the limit as delta x goes to 0. So if the limit as delta x goes to 0 of the quantity square root of x plus delta x, and then minus the square root of x all over delta x, multiply the numerator and denominator by the conjugate of the numerator. That gets rid of the square roots in the numerator, so the numerator becomes x plus delta x minus x. The x and the negative x cancel, and then I'm left with just delta x over delta x times the quantity square root of x plus delta x plus root x. The delta x's reduce, and we get the limit as delta x goes to 0 of 1 over the square root of x plus delta x plus the square root of x. When we do direct substitution, the delta x becomes 0, and I end up with 1 over 2 root x. So f prime of x is 1 over 2 root x. Remember, we do not need to rationalize when we have a root of a variable in the denominator, only when we have a root of a number. Also, I just want to again re-emphasize, because I know you love to do work, and this is the amount of work that I need to see on a test or a quiz. I need to see the original difference quotient written out like I did here in green. I need to see that you're multiplying by the conjugate. I don't want you to just go from the green to the purple, or just go from the green to the black. That would be even worse. You need to show all the work. Okay, so now I want to continue on with that last example a little bit more. So we know that, remember, the function was the square root of x, the derivative was 1 over 2 root x. So I want you to find the slope of the graph of f at the points 1, 1, 4, 2, and then look at what's going to happen at 0, 0. So pause the video, find those slopes. That should not take long since you've already done the derivative, and then unpause and we'll discuss. It'll be more like a one-way discussion since I can't hear what you say, but you'll get to listen to me. Okay, so we can see that the derivative at 1 is 1/2, so that's the slope of our tangent line there. The slope at 4 is 1/4. And what happened at 0? Well, we get undefined because we're going to end up dividing by 0. So we want to just kind of think about that for now. We'll talk a little bit more about this on our upcoming notes, not on this lesson, about what that is actually going to mean as far as the derivative is concerned. Alright, next thing though, let's stick with the same example. I want to show you how your calculator can also find and draw tangent lines for you. As far as the usefulness of this, you're not going to really be able to do this that often because, let's be honest, most tests and quizzes in here, you're not allowed a calculator. But it is kind of a cool tool to see that your calculator can do this. It also allows you to check answers on your homework and things like that. So if we take the same example that we had before, and we go to our calculator, I already put it in here, but we're going to graph the square root of x. So I put in y1, the square root of x, I did zoom standard, and I see my square root graph. Now, if you look, I have directions here. You're going to do second draw, and so if I go back to my calculator, draw is right above the program button, so if I do second draw, and I can see the fifth choice down is tangent. So if I select that, now I can put in the x value that I want to draw the tangent line at. So let's do 1. So if I type in 1 for x, and I hit enter, it draws the tangent line, and then it also gives the equation of the tangent line. So y equals 0.50000006252x plus 0.4999999, and so on. And so we can see that's what we would get for our tangent line. Notice that again, it's an approximation. This goes to the limitations of the calculator that I've mentioned many times before when we're finding zeros or vertices, that the calculation is using an approximation. So that's why it has all these decimal places, whereas we know it's just 1/2. That should be the slope. But that's what we calculated. And then we could have found the y-intercept also ourselves as 1/2 as well. So that's how you can do tangent lines with your calculator. Let's look real quick what would happen if we did the tangent line at 0. So if I hit 0, now it gives me an error, which I know should happen because it's undefined there, or the line is undefined there, or the slope, I'm sorry. So we can't draw the tangent line at 0. Okay, so differentiation is the process of finding the derivative of a function. To do that, right now we are using the limit definition of a derivative, which involves the limit as delta x goes to 0 of the difference quotient. So we need to know the difference quotient. You also want to know all of the different notations for derivative. Those are going to be key because you see a lot of the different notations all the time. You need to recognize that no matter what you see each time, it's just telling you find the derivative.